On October 1st, 2023, at 9:18 a.m. local time, the Perseverance rover recorded something in the sky above the red planet. NASA published this image on its official multimedia page, where the object was surrounded by a green ring drawn by NASA. This was not an amateur shot or a blur from conspiracy theories. It was an official NASA image from a camera mounted on the rover, showing something in the Martian sky. 24 hours later, on October 3rd, 7 spacecraft from 4 different space agencies were in perfect position to capture the closest and most detailed images of the interstellar object known as Tri-Eye Atlas. Then there was complete silence. 4 days without any news. 4 days during which NASA, China, and the UAE provided no data. And only today, on October 7th, the European Space Agency finally broke its silence. They released images of blurred white dots showing the comet with its coma. Nothing unusual, exactly what could be expected. But here is what makes their publication alarming. If ESA's images show something ordinary enough to be released immediately, why are NASA, China, and the UAE still silent? Why hasn't NASA released images from Perseverance since October 3rd? Why hasn't China, which publishes thousands of Martian images every year and never misses a chance to showcase its capabilities, released anything from Tianwen-1? ESA showed us blurred points and stated that analysis would take a week or a month. What did others see that they cannot show at all? Because here is what we know. Mathematics says that the trajectory of this object should not exist. The probability of this is 1 in a million. It emits metals in a way that violates the fundamental laws of physics. He is older than our solar system. In 21 days, he will be behind the solar disk, completely hidden from all telescopes on Earth. At that very moment, when solar radiation is either about to tear him apart or, if certain theories are correct, provide the perfect cover for what will happen next. NASA showed us something on October 2nd, 7 spacecraft. Something on October 3rd. ESA showed blurred points from October 7th, while agencies with the best cameras, highest resolution tools, and most detailed data remain silent. The question is not what Tri-Eye Atlas is. The question is what NASA and China saw that ESA either did not notice or chose not to mention. On October 7, 2025, just hours after the main part of our narrative, the European Space Agency released the first official images and data from the flyby past Mars that took place on October 3rd. These are urgent news that significantly changed the plot, so we added this bonus section to shed light on what the agency revealed and, importantly, what they are still keeping secret. Let's sort out what we now know. The silence has finally been broken. The burden is partially lifted. On October 7th, 2025, the European Space Agency did what NASA, China, and the United Arab Emirates could not. They released images, published data, and broke the silence that had lasted since October 3rd. But here's what makes this event both revealing and disappointing. What they published raises as many questions as it answers, and what has yet to be revealed may be even more significant than what has already been published. Let's start with what the agency actually showed. The ExoMars orbital spacecraft, using the Cassis camera and a system for color and stereo photography, captured a series of images from October 1st to 7. These images were compiled into an animation showing the movement of a comet against the backdrop of stars. And here it is, Comet 3 I Atlas, a slightly blurred white dot in the center of the frame, moving down the field of vision. This is the official description from the European Space Agency. A slightly blurred white dot. Before disappointment engulfs us, let's understand what we are really seeing and why this observation was extremely difficult. Cassis was designed for photographing Mars. It is optimized for capturing the bright planetary surface from a distance of several hundred to several thousand kilometers. It is designed to capture geological features, surface textures, and color variations in Martian rocks and sands. Comet 3 I Atlas was 30 million kilometers away, which is 100 times more than what Cassis usually observes. And unlike the bright surface of Mars, the comet is dim, incredibly dim. Nick Thomas, the lead researcher of the Cassis camera, stated that 3I Atlas are about 10,000 to 100,000 times dimmer than ordinary objects captured by this instrument, and it took 15 seconds of exposure to capture the image, which is extremely long for this camera. What the images show is not the comet's nucleus. Seeing the nucleus, which may be only a few kilometers in diameter, from 30 million kilometers away would be like trying to spot a mobile phone on the moon from Earth. Impossible with this instrument. We see a comet, a cloud of gas and dust surrounding its core. The European Space Agency reports that the coma is several thousand kilometers in diameter. This is significant. This confirms that Comet Atlas is actively emitting gases, releasing volatile substances as solar radiation heats its surface. This is normal behavior for a comet. This is what we expect to see. A comet approaching the sun, developing its tail. The closer she approaches, the larger and brighter the comet's nucleus becomes. The tail is not yet visible in the images. Comet tails form when solar winds blow gas and dust away from the nucleus, creating those impressive streams that can stretch millions of kilometers into space. However, the tails are much less bright than the comas. At the time of these observations, if the tail existed, it was too dim to be detected by the Cassini spacecraft. The European Space Agency notes that the tail may become visible in future observations as the comet continues to heat up and become more active. For now, nothing unusual, nothing abnormal, just a comet with a coma behaving as it should. This can even be called disappointing after all the speculations, theories, and expectations. But this is where it gets interesting. A careful study of the wording in the European Space Agency's announcement reveals what they don't say, as well as what they do say. Another ESA orbital spacecraft, Mars Express, also tried to observe Comet 331 Atlas. However, the comet has not yet appeared in these images. The exposure time was limited to half a second, the maximum that the Mars Express camera can withstand, while for ExoMars, it is 5 seconds. A shorter exposure means that the comet was simply too dim to be clearly captured. Nevertheless, ESA scientists are currently working to combine several images from Mars Express, overlaying them and adding signals from multiple frames to highlight a faint comet against the noise. This is a standard astronomical technique. When something is too dim to see in a single image, many shots are taken and combined. The signal accumulates, noise is averaged, and details merge. Why do they do this? If the images from ExoMars clearly show that the comet exists and has a coma, why make the effort to combine images from Mars Express to extract additional data? Because they are searching for something specific, something that they hope additional observations can reveal or refute. It is also worth mentioning spectroscopy. ESA attempted to use 3 different spectrometers to analyze light from 331 Atlas. Mars Express is equipped with a mega camera and a spy camera. ExoMars TGO lacks similar equipment. All 3 instruments were aimed at the comet during the flyby. Spectrometers do not just take photos. They break light into its constituent wavelengths, revealing the chemical composition of what emits or reflects that light. But here's what ESA does not clearly state. They do not report whether they successfully obtained spectroscopic data. The announcement states that it is currently unclear whether the coma and tail were bright enough for spectral characterization. Not yes or no, but unclear. This is significant because if they obtain good spectra, they know the chemical composition. They know whether there is a nickel signature. They know if the dominance of carbon dioxide is confirmed. They know if there are unusual elements or compounds that do not meet natural expectations. And if they know, they choose not to report it for now. The choice of wording that the data about the comet remains uncertain, instead of simply stating that it shows, raises questions. The announcement also contains a timeline. Scientists will continue to analyze the data over the next weeks and months, not days. This will not be a quick preliminary report, but an extended analysis with thorough research to understand what the 3 observations revealed and how the comet behaves. What exactly did the European Space Agency present? They confirmed the existence of the comet, its coma, and demonstrated images that at first glance fully correspond to normal comet activity. They slightly lifted the veil of secrecy, stating, "Yes, we have observed it. Yes, it exists. Yes, it looks like a comet." However, they were extremely cautious and did not make any definitive statements about the composition, unusual properties, or anomalies. Answers to these questions, if they exist, remain shrouded in further analysis. Now let's discuss why the European Space Agency decided to take this step now, while NASA and China remain silent. There are several possible reasons, and they are not mutually exclusive. Firstly, it is possible that ESA indeed has the least interesting data. The ExoMars and Mars Express spacecraft are capable of conducting research, but their cameras and spectrometers are not as powerful as some NASA instruments. The Mars Reconnaissance Orbiter from NASA is equipped with a high-resolution camera that could capture more detailed images. If these photographs reveal something unexpected that requires careful analysis before publication, NASA may prefer to withhold information, while ESA, with less detailed observations, feels confident in publishing. Secondly, ESA operates independently from the shutdown of the U.S. government. They are not subject to layoffs, budget disputes, or political complications. If they have completed the preliminary analysis and determined that the data is ready for publication, they can simply publish it without bureaucratic delays and waiting for coordination with agencies that are currently understaffed. Thirdly, and this is just a guess, ESA might pressure NASA and China. By publishing their observations, even if preliminary, they set a baseline. They say, here is what we have seen, here is what we are ready to share. What about you? This creates public expectations and makes the silence of other agencies more noticeable. The question everyone should be asking now is, if ESA's images show a comet looking normal, with a typical coma and no obvious anomalies, then why are NASA and China still silent? Why hasn't NASA released images from Perseverance taken on October 3rd? Why hasn't China published anything from Tianwen-1? Why haven't the data from the Hope orbiter of the United Arab Emirates been presented yet? ESA showed that observations were made and can be published. So what stops others? Colin Wilson, a researcher at ESA for the Mars Express and ExoMars projects, made an interesting remark in the announcement. He said it is always particularly exciting to observe how orbiters respond to unexpected situations. Unexpected, an intriguing choice of words. The trajectory of the interstellar object Three-Eyed Atlas was predicted months before its arrival. Its flyby was planned, and spacecraft were positioned for observation. What was unexpected here? The trajectory was not unexpected, the arrival date neither. The fact of an interstellar comet passing by Mars was also not surprising. So what does the word unexpected refer to? Behavior, appearance, or data that did not match the forecasts? We are trying to decipher mysteries by analyzing word choices, seeking clues in what is said, and what has been carefully silenced. For that is all we have. The European Space Agency has provided us with blurred white dots and cautious formulations, promising more analysis in the coming weeks and months. The silence is broken, but only to confirm that observations took place, to demonstrate the usual appearance of the comet, making the continued silence from NASA, China, and the UAE even more noticeable than before. Whatever they saw, whatever other spacecraft recorded, it is still kept secret, and the publication of data from the European Space Agency instead of answering questions only made the most important question more urgent. If what the agency showed is insignificant enough to publish immediately, what about others that require weeks or months of analysis before anyone can speak about them? Chapter 1. 9 spacecraft that hold the truth. Let's start with what we know for sure. On October 3rd, 2025, at 0400 hours UTC, the interstellar object designated as Three-Eyed Atlas reached its closest approach to Mars at a distance of 29 million kilometers. In astronomical terms, this is incredibly close, so close that we had an unprecedented opportunity, which happens perhaps once in a human lifetime. 7 spacecraft were positioned around Mars at that very moment. 7 sets of instruments, 7 different angles, 4 different space agencies, all targeting the same goal, simultaneously collecting data. The first is NASA's Mars Reconnaissance Orbiter, launched in 2005 and still operational after 2 decades in orbit around Mars. His main pride is a high-resolution photonic scientific experiment. This camera can distinguish objects as small as 30 centimeters from Mars orbit. But for the Tri-Eye Atlas, located 30 million kilometers away, the resolution will be about 30 kilometers per pixel. This may not seem very impressive until you realize something important. This is the highest resolution image of an interstellar object ever captured in the history of human astronomy. Think about that for a moment. Every other interstellar visitor we discovered, Oumuamua in 2017 and Borisov in 2019, we were only able to capture at the moment they were leaving our system, becoming distant points of light drifting away from us. We have been tracking the Three-Eyed Atlas since July, and on October 3rd we managed to take the perfect shot. The second spacecraft is Mars Express of the European Space Agency, launched in 2003. It is equipped with a high-resolution stereo camera, primarily designed for three-dimensional mapping of the surface of Mars, but the cameras do not care what they are aimed at. Mars Express is capable of creating three-dimensional structural maps of a comet's coma, the cloud of gas and dust surrounding its nucleus. This can help reveal the shape, density distribution, asymmetries, and gas ejection patterns. The third device is another European satellite, the ZOMARS Trace Gas Orbiter, a joint mission with the Russian Roscosmos. He carries aboard the Nomad device, designed for detecting trace gases in the Martian atmosphere with incredible sensitivity, and CASIS, a system for color and stereo imaging of the surface. When you point the spectrometer at the comet, you analyze the chemical composition of materials formed in another star system billions of years ago under conditions we can barely imagine. Then there is the NASA Mars Odyssey orbiter, launched in 2001, which is one of the longest operating spacecraft on Mars. His instrument, THEMIS, a thermal emission imaging system, captures infrared data, measures thermal signatures, and if the three-eyed atlas shows any unusual thermal activity, unexpected energy output, or hotspots that shouldn't exist, THEMIS will record it. The fifth spacecraft is the aforementioned Perseverance rover, located on the surface of Mars in the Jezero crater. Its camera on the upper deck has already captured something on October 2nd. But what about October 3rd? What about the moment of closest approach? Perseverance has several cameras and spectroscopic equipment. It was the only ground observer with a direct line of sight. The sixth device is the Chinese orbiter Tianwen-1, and here things become interesting in a completely different way. Tianwen-1 has been on Mars since February 2021. During this time, the China National Space Administration has published over 14,000 images from the mission, regularly releasing data and highlighting their achievements. Space exploration is a matter of national pride, and China seizes every opportunity to showcase its capabilities to the world. But for the three-eyed atlas, there is silence, not a single image, not a single release of data, not even confirmation that they attempted to conduct observations. The seventh device is the HOPE orbiter of the United Arab Emirates, also known as the Emirates Mars mission. HOPE carries a spectrometer to study the atmosphere of Mars, but is also capable of collecting spectroscopic data on a passing comet. The UAE demonstrates remarkable transparency in publishing data about their mission. They shared images, collaborated internationally, and made their findings accessible to the public. But what about the three-eyed atlas? Now we need to discuss what will happen next, because this story is not over yet. It is just beginning. At the end of November, between the 2nd and the 25th, the JUICE spacecraft of the European Space Agency, exploring Jupiter's moon Io, currently heading towards the outer solar system, will target its instruments on the three-eyed atlas. JUICE will observe the comet after its closest approach to the Sun, during perihelion, when it is most active, and when solar heat will cause maximum gas release, and if something unusual happens, it will happen then. But here lies the problem. JUICE is currently positioned relative to the Sun in such a way that communication difficulties arise. Data collected in November will not be transmitted to Earth until February 26, 2026. 4 months of waiting. 4 months of contemplating what JUICE has seen. There is still a possibility to redirect NASA's Juno spacecraft for a close encounter in March 2026. Juno is currently in orbit around Jupiter, studying the gas giant's atmosphere, magnetic field, and internal structure. But Juno has fuel, functioning tools, and the three-eyed atlas will pass about 54 million kilometers from Jupiter on March 16, 2026. The change in trajectory this September may allow Juno to fly within about 25 million kilometers, closer than its approach to Mars. This is close enough for detailed imaging, close enough for spectroscopy that could finally answer some questions troubling astronomers. But NASA has not yet approved this maneuver, and with the current government shutdown, when 15,000 NASA employees are on forced leave and the agency is effectively paralyzed, this decision is stuck in a bureaucratic vacuum. We have 7 spacecraft that observed the flyby on October 3rd. We have 1 spacecraft that captured preliminary images from October 2nd. We have future observations scheduled for November and potentially for March next year. And out of all this, from all these tools, all these agencies, all this data, what has been published for the public? An image from the Skycam Perseverance taken on October 2nd, published on NASA's Raw Images page, showing something in the Martian sky outlined in green and nothing else. Chapter 2. Images from Skycam Perseverance, October 2nd. Let's talk about what NASA has actually published, because these are not speculations or rumors. These are official images from the Raw Images Archive of Mars 2020. They exist, they have timestamps, they are labeled, and anyone with internet access can view them right now. The image was taken on the 642nd Sol, which counts Martian days since the landing of Perseverance in the Jezero crater. The 642nd Sol corresponds to October the 2nd, 2025, in Earth time. The time on Mars is 9 hours, 18 minutes, and 48 seconds. Local solar time. It's morning on Mars. The sun rose about 3 hours ago. The camera that took this shot is officially called Perseverance Skycam. It is mounted on the top of the rover, on a flat surface where most scientific instruments are located. Unlike navigation cameras or cameras mounted on the mast facing forward to scan the horizon, the Skycam is directed straight up. It is designed to observe the Martian sky, tracking atmospheric phenomena, dust whirlwinds, clouds, and changes in atmospheric transparency during the onset and disappearance of dust storms. However, on the 2nd of October, it recorded something else. The first image shows a round object, somewhat distorted due to the wide-angle lens of the camera. At the top of the frame, there is a clearly visible object circled in green by the NASA image processing team. It is important to realize that this is not just an amateur astronomer's observation of a blurry pixel. This is the official multimedia page of NASA with an annotation added by agency staff, highlighting something in the Martian sky. The second image is wider, showing the full field of view of the Skycam. The frame shows the round body of the camera with characteristic distortions at the edges, and there, in the upper right corner, the same object appears. It's faint, but it's there. It's not a dead pixel, not a trace of cosmic radiation, and not a processing artifact. He moves between frames, indicating real movement relative to the camera. Now let's consider the technical significance of this moment. Skycam is not a high-resolution setup. It is designed for broad monitoring rather than detailed shooting of distant objects. Her goal is atmospheric observations, tracking phenomena occurring in the Martian sky at a relatively close distance. The fact that she captured the object says a lot. It means the object was bright enough to register on a camera not intended for astronomy, bright enough to stand out against the Martian daytime sky, which, although much dimmer than Earth's due to Mars's thin atmosphere, is still not as dark as at night. The shot was not taken in the evening or at dawn. It was mid-morning, and yet the object is present in the frame. At the time of shooting, the distance to the object was about 30 million kilometers. This is the distance between Tri-Eye Atlas and Mars on October 2nd. For comparison, this is about 80 times the distance between the Earth and the Moon. It is a vast chasm of empty space, and the camera, aimed upwards, with little expectation of capturing anything beyond Martian weather, recorded it. But this is where the temporal context becomes important. October 2nd was not the moment of closest approach. That occurred 24 hours later, on October 3rd. The object continued to approach, growing brighter as it moved toward Mars. Thus, the question arises, what did the Perseverance mission capture on October 3rd? We do not know, since NASA has not yet published these images. Usually, the archive of raw images from Perseverance is updated within a few days after receiving the shots, sometimes even within a few hours. The rover takes thousands of photographs, which are transmitted to Earth via Mars orbiters acting as relays. The data arrives at Deep Space Network stations in California, Spain, and Australia. They are then redirected to the Propulsion Laboratory in Pasadena, from where they are uploaded to the public archive. This process is mostly automated. No human intervention is required to decide what to publish and what not. Images simply pass through the system and appear on the website. This scheme has been functioning this way for many years. Curiosity images appear as scheduled. Perseverance images also appear regularly, but it seems not so for the images of October 3rd. Not so with images taken at the moment of closest approach. Not so with images that could show what the Three-Eye Atlas looked like when it was at its closest point to Mars, when it was brightest, when it could be best observed with any camera made by humans. These images are missing. One might assume that Perseverance was busy. It is a working rover conducting a mission to collect rock samples for studying Martian geology and searching for signs of ancient microbial life. It has a schedule and priorities. Perhaps the scientific team did not assign him the task of observing Tri-Eye Atlas on October 3rd. Perhaps they were focused on drilling another sample or navigating to a new location. However, we know that this is not the case. We learned from the official mission plan that several spacecraft coordinated observations of Tri-Eye Atlas during its flyby of Mars. This event was considered significant. NASA publicly announced its intention to observe it. We also know that Perseverance has several cameras that could be pointed up at any time during the Martian day corresponding to the 16th day of the 14th month. The rover does not need to stop working to take a picture of the sky. He can do both. The camera aimed at the sky is always on. It is always pointed upwards, ready to capture everything that passes overhead. So where are these images? There is another point to consider. The image from October 2nd was not highlighted or presented in NASA's news. It was not released with a press release. It was not included in mission updates or news articles. It simply appeared in the archive of raw images, like thousands of other photos, with basic metadata and no commentary. A green circle annotation was added later, presumably when someone browsing the archives noticed the object and marked it. NASA's multimedia team often adds annotations to interesting images, pointing out features of geological interest or unexpected atmospheric phenomena. This is standard practice, but here, time is of the essence. The annotation appeared, the image began to circulate on social media, and then silence reigned. The question arises about the images from orbital spacecraft, as Perseverance was not the only camera aimed at the triple object Atlas that day. The Mars Reconnaissance Orbiter, Mars Express, was in position, and Odyssey was active. Orbital devices have much more powerful cameras than the rover's camera. They were supposed to capture significantly better images, and perhaps they did. We just haven't seen them. Here, a certain pattern begins to emerge, and it is not so subtle. On October 2nd, a day before the closest approach, an image appears showing Atlas in the Martian sky. It is published automatically as part of the standard data stream. Someone notices it, someone adds a comment. This begins to spark interest. And then, on October 3rd, the day of the closest approach, when 7 spacecraft were simultaneously observing, and we were supposed to see the best images of the interstellar object, nothing is published. Neither from Perseverance, nor from the Orbital Reconnaissance Vehicle for Mars, nor from Mars Express or Odyssey, nor from others. The automatic data stream seems to have stopped moving, or more accurately, it is being held. Data does not just disappear, it exists somewhere. На жестких дисках лаборатории реактивного движения, на серверах Европейского центра космических операций, в архивах Китайского национального космического управления они существуют, но нам не дают их увидеть. Почему так происходит? Why did NASA publish the image of October 2nd, allow it to be annotated and distributed, and then hold back everything that came after? In fact, there are only 2 possibilities. The first is the mundane technical issues, data corruption, communication failures, and government shutdowns affecting normal operations. Perhaps images are queued somewhere, waiting for processing by staff who are currently absent. Perhaps there is a perfectly reasonable explanation that has nothing to do with what the images show. The second possibility is less trivial. The images reveal something unexpected that requires careful analysis before publication. Possibly something that needs to be discussed and agreed upon by several space agencies before anyone speaks. The snapshot from October 2nd shows something in the sky, a point of light, nothing more. But points of light do not require coordination between NASA, ESA, CNSA, and the UAE. Points of light do not require silence. Points of light are published automatically, analyzed by the scientific community, and discussed openly in academic articles and press releases. So, what did the camera see on October 3rd that the point of light on October 2nd did not prepare anyone for? What changed in those 24 hours as Atlas approached, the resolution improved, and the details became clearer? We do not know, but 7 spacecraft know. 4 space agencies also know. And somewhere in secure institutions on 3 continents, people are examining images that we are forbidden to see. Chapter 3. 4 Days of Silence. What happened next? Today is October 7th, 2025. It has been exactly 4 days since the closest approach, 96 hours since 7 spacecraft observed the Object 3, at last in the most detailed resolution ever achieved for an interstellar object. And for these 96 hours, The silence from the world's space agencies has been, to put it mildly, deafening. Let's define what a normal state of affairs is, because to understand why this silence is significant, one must realize how much it deviates from standard procedures. When missions to Mars receive interesting data, they are quickly published. NASA's orbital probe for Mars exploration regularly publishes high-quality images of the Martian surface, often within days of receiving them. These images are not just routine maps. They are high-resolution observations of dust storms, wall collapses in craters, newly formed craters from impacts, and seasonal changes on polar ice caps. These images appear on NASA's website with explanatory captions. They are featured in press releases shared on social media by NASA's Public Relations Office. The European Space Agency does the same with Mars Express. When a spacecraft captures something significant, be it a dusty storm, a mineral deposit, or an unusual geological formation, ESA publishes it, writes articles, provides context, and invites planetary scientists to comment. Information is communicated to the public in the usual manner. But here's where it gets really interesting. China's approach to achievements in space, if one can put it that way, is even more aggressive in terms of publicity. The Chinese National Space Administration views space exploration as an extension of national prestige. Each successful landing, every orbit, every scientific discovery is an opportunity to showcase technological capabilities to the world. When Tianwen-1 entered Mars's orbit in February 2021, CNSA released images within a few hours. When the Zhirong rovers landed on the surface in May of that year, the images arrived immediately. High quality, color-corrected, professionally processed. Since the arrival of Tianwen-1 on Mars, CNSA has released more than 14,000 images from the mission, averaging almost 12 images a day for 4 consecutive years. They show the surface of Mars, rover tracks, rocks, dunes, a Chinese flag painted on the lander. They show everything because this demonstration proves that China can compete with NASA on equal terms. So when the 3 Atlas, the most significant interstellar object ever to pass through our solar system, approached within 30 million kilometers of Mars, what did CNSA release? Nothing. Not a single image. Not a single dataset. Not a single press release. Not even confirmation that Tianwen-1 attempted any observations. Such behavior is not normal for the China National Space Administration. This breaks all the patterns they established over 4 years of operations on Mars. If Tianwen-1 had captured images of the object 3I Atlas, and if those images showed exactly what everyone expected to see, a typical comet with a characteristic coma and tail, CNSA would have published them immediately. They would celebrate the capture of an interstellar visitor and use it as proof of their advanced imaging capabilities. They would likely outpace NASA and release their data first to demonstrate that China reached there before America. But they did not do this. They remained in complete silence. One could argue that the government shutdown in the United States explains NASA's silence, and to some extent, this is a fair remark. As of October 1st, 2025, more than 15,000 NASA employees were put on forced leave, which is 83% of the agency's workforce. The Rocket Propulsion Laboratory, which manages most of NASA's Mars missions, operates with a minimal staff. The data processing streams, which usually run smoothly, are now slowed down by bureaucratic difficulties. But here's the problem with this explanation. The government shutdown only affects the United States. It does not impact the European Space Agency. It does not concern the China National Space Administration. It does not involve the United Arab Emirates Space Agency. These organizations are independent, located on different continents, and have different financial structures and political situations. The U.S. budget is formed by the member states of the European Union. CNSA is accountable to the Communist Party of China. The UAE's space program is funded by the Emirate government. None of them depend on American budget disputes. They have no employees on forced leave. They have no operational reasons for delaying the publication of data on 3 Atlas. And yet, they remain silent. CNSA is silent. The UAE is silent. We need to talk about how coordination looks in the space community, as these agencies do not coordinate their actions on all issues. In fact, they rarely coordinate anything beyond basic safety protocols and frequency distribution to avoid interference in each other's communications. NASA and CNSA in particular have relationships best described as competitive. Not hostile, but competitive. There are legal restrictions on cooperation between American and Chinese space programs. The Wolf Amendment, passed by the U.S. Congress in 2011, prohibits NASA from using federal funds to collaborate with China in space activities without explicit congressional approval, meaning NASA and CNSA do not freely exchange data. They do not cooperate on joint missions. They do not coordinate their scientific announcements. They compete, observe each other, and try to surpass one another. When China lands a rover on the far side of the moon, NASA responds by accelerating its Artemis program. When NASA lands Perseverance on Mars, China responds with the landing of Zhurong. This is the dynamics of interaction. This is how it happens. Therefore, when NASA and CNSA simultaneously remain silent about an event, it is not ordinary competition. It is coordination. It is something entirely different. The same principle applies to ESA. Although ESA and NASA collaborate on many projects, they remain separate organizations with different priorities. When ESA has interesting data, they publish it independently. They do not wait for permission from NASA. They do not consult Washington before releasing images from Mars Express. They act autonomously, but not this time. This time, ESA is silent, as are NASA, CNSA, and the UAE. 4 agencies, 4 different continents, 4 different political systems, all silent about the same event. There's a phrase that fits. When everyone speaks, no one listens. When everyone is silent, everyone hears the silence. Consider what is needed for this to happen. Think of the conversations that should have taken place. NASA staff connect with colleagues from ESA. ESA reaches out to CNSA. Someone is coordinating actions with the UAE, agreeing that nothing will be published until all data is analyzed, until everyone agrees on what the data means, and until they decide how to present it to the public. These are not the conversations that happen during ordinary observations. This is not what is discussed when a comet passes through the solar system. These are conversations that happen when something unexpected appears in the data, and no one wants to be the first to speak of it aloud. There is a certain pattern in how scientific anomalies are processed. When something strange appears in the data, the first instinct is not to publish immediately. First, you need to check, confirm, and ensure that what you see is real and not a glitch in the tool, a processing error, or a cosmic ray that looks unusual. Therefore, you conduct diagnostics, reprocess the data, compare it with calibration standards, and ask colleagues to take a look at it. You very carefully and methodically rule out all possible mundane explanations before even considering the possibility that you might be witnessing something truly anomalous. This is good science. It should be like this. The problem is that usually it doesn't require 4 independent space agencies to coordinate their silence. If only, perhaps, they all saw the same anomaly, if they all needed to confirm it, if everyone had to be absolutely sure before anyone said anything, because once it was said, it could not be undone. And here we are, October 7th, 4 days after the closest approach. The data is somewhere on the servers of the Jet Propulsion Laboratory, in the archives of the European Space Agency, in the databases of the China National Space Administration, in the mission control systems of the United Arab Emirates. There are images, high-quality shots, spectroscopic data, thermal readings, everything that 7 spacecraft recorded in those critical hours when 3 Atlases were at their closest point to Mars. And none of this data, not a single byte, was transmitted to the scientific community or the public. The image from the heavenly camera on October 2nd remains the only visual evidence we have. A point of light in the Martian sky, a day before the closest approach, a day before the resolution improved dramatically, the day before the moment when 4 space agencies decided they needed to remain silent until they understood what they had seen. The silence continues, growing louder each day than any other statement. Chapter 4. What could it really be? Theories. While we wait for the space agencies to break their silence, let's talk about what 3 Atlases might represent. The answer to this question determines whether we are witnessing a routine astronomical event or something that will radically change humanity's understanding of its place in the universe. Currently, 4 main theories are being discussed, ranging from simple to extraordinary. Each of them has their own evidence. Each faces certain problems. And understanding all 4 is crucial to realizing why the silence from those who saw the data on October 3rd may be so carefully maintained. Theory 1. An ancient reconnaissance device. This idea is gaining popularity in certain internet circles, and while it sounds like science fiction, the mathematical justifications behind it are quite convincing. The theory is as follows. Three atlases are not a natural object. This is a probe, a spacecraft launched by an intelligent civilization somewhere in the Milky Way between 7 to 14 billion years ago. To understand this, it is worth considering that our Sun is only 4.5 billion years old. Earth is 4.5 billion years old. The first complex multicellular organisms on Earth appeared about 600 million years ago. Humans, including anatomically modern humans, have existed for only 300,000 years. But three Ayatlas may be older than all of this. It could have been built and launched when the universe was less than half its current age, when our solar system did not yet exist, when the materials that eventually formed Earth were still scattered in interstellar space within clouds of nebulae. Why would civilizations create something like this? The hypothesis suggests it is an observational probe, a recorder, a device sent to travel through the galaxy to document cosmic events, to collect data over geological epochs. Not a crude ship, not something that expects to return, but an automated system, possibly powered by something we do not understand. Perhaps it had been dormant for billions of years and activated only upon encountering something worthy of observation, like the solar system, like planets in the habitable zone, like us. Some versions of this theory suggest that the three Ayatlas are not interstellar artifacts, do not transport living organisms, but contain information, knowledge, and technology. This inherited legacy of a civilization that realized it was dying wanted something of it to be preserved. A message in a bottle, thrown into the cosmic ocean billions of years ago, now washed ashore. The synchronicity is intriguing. Three Ayatlas entered the outer boundaries of our solar system about 8,000 years ago, coinciding with the dawn of written human history. At the time when the first cities were being built in Mesopotamia, when agriculture transformed nomadic tribes into settled societies, if you were a civilization designing a probe to observe an evolving intelligent species, you might program it to arrive at this very stage. Not too early, when there is nothing interesting to observe, and not too late to miss a critical transitional period. This theory frightens some people because if it is true, then we have been under observation for thousands of years, and we did not know about it. The second theory, an active reconnaissance mission. It resembles the initial theory but is more immediate and purposeful. Instead of being an ancient artifact wandering for billions of years, this theory suggests that the three Ayatlases were intentionally sent to our solar system relatively recently, possibly within the last few million years, by a civilization that discovered our sun and wanted to take a closer look. The trajectory confirms this. The object doesn't just pass by randomly, it is almost perfectly aligned with the plane of the ecliptic, a flat disk around which all planets rotate, passing close to several worlds. Mars in October, Jupiter in March. If you are planning a reconnaissance mission to study various planetary conditions and observe different types of worlds in one system, this is exactly the trajectory you would choose. The retrograde orbit is further confirmation. Three Ayatlases move in the opposite direction of the planet's orbit, which is actually advantageous for the reconnaissance mission as the object travels through the solar system while the planets move towards it. If he wanted to deploy smaller probes, small observation devices, reverse motion means these probes could be released with minimal energy expenditure and would still intercept the planet's orbits. The planet's own orbital speed does half the work. Heavy Lob, an astrophysicist from Harvard, closely monitoring this object, described it as a potential space reconnaissance mission. Not necessarily hostile, not necessarily friendly, just observant. A civilization conducting research, collecting data on planetary systems throughout the galaxy, and we found ourselves as one of the stops on its route. Theory 3. A natural comet with exotic chemistry. This is the common explanation that most astronomers accept by default. The three Ayatlas are just a comet. It formed in another star system billions of years ago, was ejected due to gravitational interactions with planets or passing stars, and has been wandering through interstellar space ever since. Now, it is passing through our solar system. There is nothing rational in this, nothing designed, just a piece of ice and stone with frozen gases doing what such pieces do. Unusual chemistry explained by formation conditions not observed in our solar system suggests that Tri-Ayatlas likely originated from the thick disk of the Milky Way, a region of old stars with differing metallic compositions, elemental ratios, and planetary formation conditions. Comets forming in such environments can have differences in composition: more carbon dioxide, less water, different ratios of metals and volatiles. Strange, but not impossible, just different. What about the trajectory? Statistical randomness? Yes, the odds are low, but low odds are not zero. In a galaxy with hundreds of billions of stars, each potentially ejecting comets into interstellar space, sooner or later, one of them will have a trajectory that looks suspiciously purposeful, just by random chance. Perhaps this is exactly such a comet. This theory has the advantage of not requiring any extraordinary assumptions. No ancient civilizations, no technological artifacts, no intelligence. Nature simply does what it knows, creating objects with a wide range of properties, and from time to time one of them looks strange enough to spark human curiosity. The fourth theory is a hybrid hidden device. This is the most creative of the theories proposed by those pondering how an advanced civilization might disguise its technology. The idea is simple, yet elegant. There is no need to build an obviously artificial spacecraft. Instead, find a natural object, an asteroid or a comet, and carve it out. Use natural stone and ice as a shell for camouflage, hiding your real technology inside. On the outside, it looks like a comet. She has a coma because you release gases to maintain the illusion. She has patterns of gas release that look natural because you create them to seem so. Any telescope aimed at it sees exactly what it expects to see. A comet, just a comet, nothing unusual. But within its structure or machines, there is a purpose. This theory explains much. She explains why Tri-Atlas can exhibit comet-like behavior while also demonstrating anomalies that do not fit the comet model. It is both. A comet shell surrounded by a technological core, the perfect camouflage for interstellar travel. You do not attract attention. You do not cause alarm. You pass through solar systems, looking like harmless debris, carrying out your mission. This hypothesis has been seriously considered in astrobiology circles. If humanity ever creates interstellar probes, we might use this very strategy, extracting resources from an asteroid or comet, using it as both a resource and a disguise. This is effective, it is smart, and if we could think of it, then another civilization could have thought of it first. So, there are four theories: an ancient artifact, active reconnaissance, a natural comet, and cloaking technologies. Each of them has its own arguments and supporters, leading to completely different conclusions about what we should do next. Somewhere, in secure laboratories, where data from October 3rd is analyzed, people study images, spectroscopy, and thermal data, trying to determine which of these theories is supported by the gathered evidence. Or perhaps they are analyzing data that doesn't fit any of these theories. Maybe they see something unexpected, something that requires the development of a fifth or sixth theory that hasn't been publicly discussed because no one anticipated it would be necessary. We can speculate, build theories, create models, and discuss them online, but those who know, who have seen what the 7 spacecraft or the data from October 3rd represent, are not speaking, not with us. And this silence, more than any theory, tells us that what the three-eyed atlases represent is important enough to be very careful about how the answer will be revealed. Chapter 5. Mathematical Impossibility, 1 in a million. Let's talk about numbers. Not about the comfortable numbers we use in everyday life, but about the uncomfortable ones that make astronomers uneasy and pose questions they are unsure they want answers to. Three-eyed atlases on a trajectory that shouldn't exist. It cannot exist, and it should not. This distinction matters. In a physical sense, there is nothing impossible in their path. It does not violate any laws of motion and does not contradict orbital mechanics. But the probability that this trajectory arose by chance is so negligible that calling it unlikely would be as appropriate as calling the Pacific Ocean wet. So, what are we dealing with? On October 3rd, 2025, three-eyed atlases passed within 29 million kilometers of Mars. On March 16th, 2026, they will pass within 54 million kilometers of Jupiter. 2 planetary collisions, 2 of the most scientifically interesting objects in our solar system after Earth, both in one flyby, both at a distance close enough for detailed observation. Let's figure out why this is mathematically unusual. First, the alignment of orbital planes. The plane of the ecliptic is a flat disk around which the Earth and other planets revolve around the Sun, serving as a reference plane for the solar system. If one imagines the solar system as a vinyl record, The plane of the ecliptic would be the surface of the record, and the planets would be grooves spiraling around the center. Most comets and asteroids belonging to our solar system orbit in roughly the same plane, with slight deviations, because they all formed from a single rotating disk of material billions of years ago. The trajectory of the three-eyed atlas is tilted at 4-whole 89 degrees relative to the ecliptic. At first glance, this doesn't seem like much, less than 5 degrees, almost in the same direction. But here's the thing. For an interstellar object, for something that comes from outside the solar system and has no connection to our history of formation, there is no reason for it to be aligned in any way. It could come from any direction, above the plane of the ecliptic, below it, perpendicularly. Most possible trajectories in three-dimensional space will not lead him to the ecliptic. The probability of everything aligning is about 0.2%, meaning 2 out of 10,000. And this is where it becomes truly uncomfortable. These probabilities are independent. The alignment relative to the plane of the ecliptic and the timing of approaches to the planets are separate factors. To obtain both probabilities, they must be multiplied. 0.2% multiplied by 0.2% equals 0.004%, which is 4 out of a million, or roughly 1 in 250,000. But we do not stop here, as there is another factor. The trajectory not only passes by Mars and Jupiter, but it does so to maximize observational opportunities. The closest distances are neither too near nor too far. If the object were too close, it would rush past before the instruments could register it. If too far away, the resolution would be insufficient. The distance at which the three-eyed atlas is located is essentially ideal for observation by space devices. Considering the optimization of approach distances, the overall probability drops even lower. Scientists estimated it at about 0.005%. That's 5 out of a million, 1 out of 200,000. Consider what 1 out of 200,000 means. If you shuffle a deck of cards and deal yourself 5 specific cards in a certain order, it is more likely than this trajectory occurring by chance. If you buy a lottery ticket, you have better chances of winning a significant prize than the three-eyed atlas randomly following this path. Now let's talk about the 5-degree tilt, because this is where mathematics becomes even more intriguing. Why exactly 5 degrees? Why is it not perfectly aligned at 0 degrees? Why not 10, 20, or some other random value? There is a hypothesis that explains this, and it is elegant enough to cause concern. It's called the theory of the transit viewing cone. Here's how it works. Imagine you are an alien civilization on a planet orbiting a star somewhere in the galaxy. You want to discover other planetary systems. How do you do this? Just like human astronomers do, through transit studies. You watch the stars and wait for the planets to pass in front of them, causing slight fluctuations in brightness. This is the most successful method we have developed for finding exoplanets. Thousands of worlds have been discovered this way. But here's the catch. You can only discover planets that pass in front of your star from your point of view. If you are not in the right position, if you do not look at the star from the right angle, you will not see the transit. A planet may exist, but you will never know about it. This means that there is a narrow cone of space, a specific angle of view from which the planets of our solar system can be detected through transit studies. If an alien civilization is within this cone, it can detect Earth, Mars, and Jupiter. They will see all 3 planets passing in front of our sun from their observation point. How wide is this cone? It depends on what you are looking for. If you are only interested in Earth-sized planets, the cone will be quite narrow, perhaps within 1 or 2 degrees. But if you are interested in discovering everything, including the asteroid belt that forms a thick ring of debris between Mars and Jupiter, the cone expands significantly. The asteroid belt is about 150 million kilometers thick, and from a distant observation point, objects passing in front of the sun from any point in this belt will be detectable. Mathematical calculations show that this is a cone approximately 10 degrees wide. Any civilization located within this 10-degree range above or below the ecliptic plane will be able to detect our asteroid belt, our main planets, and Earth. They will understand that this solar system is worth exploring. Now, if you were that civilization and wanted to send a probe to study our system, what trajectory would you choose? Would you launch it in the same direction? Would you direct it straight down the center of the cone that allowed you to make the initial detection? This trajectory would be inclined at 5 degrees, exactly halfway between 0 and 10. An object called Tri-Eye Atlas is inclined at 4.89 degrees, essentially corresponding to 5 degrees considering measurement accuracy. It may be a coincidence, but a very specific coincidence. It is not just roughly aligned. It is aligned in such a way that it makes complete sense if the object was indeed deliberately aimed at our solar system by a civilization that discovered it through transit studies. The massive Three-Eye Atlas adds another layer of complexity to this puzzle. Based on its brightness and estimated size, the mass of the object is at least 33 billion tons, possibly even more. For comparison, the International Space Station, the largest man-made structure in space, weighs about 420 tons. The Space Shuttle, when fully loaded, weighed about 2,000 tons. The SpaceX Starship rocket, the largest ever built, weighs 5,500 tons at launch. 3 Atlas IIs are 6 million times heavier than the Starship. 6 million. If this object is artificial, if it was constructed rather than formed naturally, the engineering requirements will surpass anything humanity can achieve, to a level that makes comparison almost meaningless. We speak of a civilization capable of manipulating billions of tons of materials, accelerating them to interstellar speeds, and sending them on trajectories precise enough to cross distances between planets separated by hundreds of millions of kilometers. This is a level of technological complexity that implies if the 3 eyes of Atlas is a probe, it is not just beyond our understanding, but completely inaccessible to our perception, like the difference between a stone axe and a particle accelerator. Loeb gathered what he calls the family of anomalies. 3 eyes of Atlas. The trajectory is anomaly 6, but it is the one that ties everything together, as the trajectory determines everything else. Where the object moves, what it encounters, and when it happens. If the trajectory is intentional, if it is targeted, then all other anomalies must be reconsidered in this context. A natural comet with an unlikely trajectory is merely curiosity. An artificial probe on a carefully calculated trajectory is something entirely different. This means that someone has aimed this device at us. This means that someone wanted it to be here. This means that someone was specifically interested in our solar system. Probability calculations prove nothing. 1 in 200,000 is unlikely, but not impossible. Incredible things happen. People win the lottery, lightning strikes the same place twice, cosmic coincidences occur. But when you are a space agency, like NASA, ESA, or CNSA, and you look at data from October 3rd and see something with a 1 in 200,000 probability doing something unexpected, something that doesn't quite fit the comet model, you start asking questions, difficult questions. Questions about whether to publish the data immediately or take time to understand what you see. Questions about whether the trajectory is trying to convey something to you. Questions arise about whether someone or something intended for us to notice this object, prompting us to ask these specific questions. Mathematics does not lie. A trajectory is a trajectory, and probability is what it is. 1 in 200,000. These are the numbers. What do they mean? What conclusions can we draw from them? This is the question that troubles astronomers, and somewhere in the data from October 3rd, in the images we were not allowed to see, may lie the answer. An interstellar object accidentally arriving within 5 degrees of the ecliptic plane. About 0.12%, 2 out of 1,000, is already quite unlikely, but this is just the beginning. Now about time. The 3 eyes of Atlas not only crossed the ecliptic plane, they crossed it at precisely those places to meet Mars and Jupiter. Consider what this requires. Mars orbits the Sun at an average distance of about 230 million kilometers. Jupiter orbits at a distance of about 780 million kilometers. In order for the 3-eyed Atlas to pass close to both planets, it must cross their orbital paths when the planets are in their positions, not on the opposite side of the Sun, not months before or after, but precisely at the moment the object passes. Chapter 6. October 29th. A hidden moment of truth. Observers around the world have circled the date, October 29th, 2025. Just 22 days away. That is when the 3-eyed Atlas will reach perihelion, its closest point to the Sun. 1 whole 36 astronomical units, about 203 million kilometers, just inside Mars's orbit, just outside Earth's orbit. And this is what makes this date so critical, potentially revealing, and, unfortunately, inaccessible. The three-eyed atlas will be completely hidden from all telescopes on Earth. The geometry is simple, yet inevitable. As the object approaches perihelion, from Earth's perspective, it moves toward the Sun, then passes behind it. If all goes according to plan, it will reappear on the other side at the end of November. But during this period of closest approach, when solar radiation reaches its maximum intensity, when the comet should be most active, when something unusual might happen, we will not be able to see it. The Sun will be in the way, literally between us and the object we are trying to observe. This is not just an inconvenience, it is a critical gap in our observation schedule, as it is during the perihelion that comets reveal their true nature. Far from the Sun, they are cold, inert, in a state of rest. Volatile substances, frozen gases trapped in their ice, remain frozen. Emissions are minimal, activity almost absent. They are just dark chunks of material drifting in space. But as they approach the Sun, with increasing solar radiation, everything changes. The surface heats up, the ice begins to sublimate, transitioning directly from solid to gas, bypassing the liquid phase. This causes emissions of vapors and dust. A cloud expands, forming a tail. The comet seems to come alive, truly driven by energy from the Sun. В перигелии эта активность достигает максимальной интенсивности. Температура поверхности может подняться настолько, что испарит материалы, которые были стабильными всего несколько недель назад. Сложные органические молекулы распадаются. Subsurface ice, exposed due to erosion, begins to emit steam. If a comet is to fragment, if it is to break apart under thermal stress, it will happen precisely at perihelion. The three-eyed atlas of perigelium represents about 12 gigawatts of solar energy hitting its surface, equivalent to the power of about 12 large nuclear power plants. Constantly, for several hours, focused on an object just a few kilometers in diameter, the thermal load is colossal, the stresses immense. If the three-eyed atlas is a natural comet, we can expect certain things to happen. Massive gas emissions and a sharp increase in brightness as a larger surface activates. The developing tail, streaming behind it, forms when solar wind pushes ejected materials from the Sun. Fragmentation may occur if there are structural weaknesses in the core. This is standard behavior for comets at perihelion. We have observed this many times with the comets of the solar system. But if the Atlas trio is something else, if the hypotheses about its artificial origin have any validity, then perihelion may reveal completely different behavior. And this is where difficulties arise for traditional approaches. In orbital mechanics, there is a maneuver called the Oberth effect. When you are near a massive object deep in a gravitational well, any change in speed has an amplifying effect on your orbit. Spacecraft use this regularly. You wait for the closest approach at perihelion when near the Sun, then ignite your engines. The speed change achieved at perihelion results in significant alterations in orbital energy. This is the most economical way to substantially change an orbit. Now, if the Atlas trio wants to change its trajectory, if it wants to slow down and become gravitationally bound to the Sun, rather than continue its hyperbolic path, then perihelion is the moment to do so. You would wait until you are behind the Sun, hidden from Earth's view, and perform the so-called Oberth maneuver. You would slow down, and instead of flying past the Sun and leaving the solar system, you would descend into an elliptical orbit. You would stay. Avalov noted that the time for this maneuver was optimal. The object would be hidden from Earth. The thermal and radiation environment around perihelion would mask any propulsion signals. If you wanted to conceal a trajectory change, this would be the perfect time and place for it. Moreover, if the Atlas triad is the mothership, carrying smaller probes intended for deployment toward inner planets like Earth or Venus, then the retrograde orbit makes perihelion the ideal point for deployment. The object moves in the opposite direction compared to the orbital motion of the planets. A probe released at perihelion with minimal speed could cross Earth's orbit with relatively low energy expenditure. The planet will actually collide with the probe as both objects orbit the Sun in opposite directions. This is the Trojan horse scenario. It looks innocent. It seems to be a comet passing by and doing what comets do, but in a hidden moment, at perihelion when no one can observe, something else happens. A probe unfolds, maneuvers, revealing its purpose. But does anyone really consider this likely? Most astronomers would answer negatively. Most planetary scientists would argue that the Atlas trio will behave exactly as a comet should. It will brighten, possibly disintegrate, and when it appears at the end of November, we will see exactly what we expect. A comet that has survived perihelion and is now heading back into interstellar space. However, the fact that we cannot observe this during this critical period worries people. This concern is so great that several professional observatories have developed plans to observe the object's reappearance at the end of November with unusual intensity. This raises serious concerns, prompting space agencies to prepare their instruments for when the Triple Atlas object becomes visible again. That's the uncomfortable truth. If the Triple Object Atlas hides behind the sun and emerges from there transformed, we will miss the moment of transformation. We will have data before and after, but not during the process. We will know that something has changed, but we won't be able to understand how, why, and what exactly happened in those hidden hours. There is a philosophical parallel. There is a thought experiment about a falling tree in the forest. If an interstellar object does something unusual at perihelion, and no one can observe it, did it actually happen? But it's not quite so because we will still find out. We will understand by what happens next. If the Triple Object Atlas appears at the end of November on a different trajectory, or with different properties, or accompanied by smaller objects that weren't there before, we will understand that something has happened. We just won't know what to call it. Data from October 3rd. Images we haven't seen could provide context. If these images reveal something unexpected, indicating that the Triple Object Atlas behaves unlike a typical comet, then the events at perihelion will become exponentially more significant. This will be the moment when we either confirm that it is just an unusual natural object or confront something that will make us rethink everything. 22 days, 3 weeks, and 1 day. That is how much time is left until the hidden moment when the Triple Object Atlas disappears behind the sun and we lose the chance to observe what happens next. We will enter a period of waiting and reflection, hoping that when the object reappears, it will still be just a comet returning to interstellar space, hoping that he had not changed, that he had not remained, hoping that everything about these 7 spacecraft or the 3rd of October was interesting yet understandable, and that the perihelion would be just as interesting and understandable. But hope is not data. Hope is not observation. Hope is what you rely on when you lack the information needed for a conclusion. And now, as the silence from space agencies continues, with the days until perihelion counting down, hope is mainly what we have. It is the knowledge that at the end of November, when the Triple Object Atlas reappears, we will finally know if our hope is justified. Among all the anomalies related to the Triple Object Atlas, there is one that stands out from the rest. One that is truly difficult for astronomers to explain through natural processes. One that, upon understanding the basics of physics, makes you stop and rethink everything you thought about this object. It is nickel. Or, more precisely, nickel without iron. Let's start with the basics of cosmic chemistry. When massive stars die, exhausting their nuclear fuel and collapsing into supernovae, the explosion creates heavy elements through nuclear synthesis. Carbon, oxygen, silicon, and yes, metals like nickel and iron. These elements are formed under extreme temperatures and pressures in the core of a supernova and then ejected into space, ultimately becoming part of new star systems, new planets, and new comets. Here is the key point. Nickel and iron are created together. They are formed in the same stellar layers during the same nuclear processes, have similar atomic structures, and connect in a similar way. In nature, and in every natural object we have ever studied, from meteorites to asteroids and comets, nickel and iron are always found together. Finding one element without the other is like finding smoke without fire. Such a thing does not happen naturally until the appearance of comet Triatas. In July and August of 2025, a very large telescope in Chile conducted spectroscopic observations of comet Triatas. Spectroscopy works by analyzing the light emitted from an object. Different elements absorb and emit light at specific wavelengths, creating a unique fingerprint. One can determine the composition of an object by looking at these spectral lines. A very large telescope detected 22 distinct emission lines of nickel in the gas cloud around comet Triatas. 22 is not a weak signal. It is a strong, undeniable detection. The comet produced neutral nickel atoms in its coma, releasing them as gas evaporating from the surface. But here's the problem. The emission lines of iron were zero. Nothing, a complete absence. The instrument was sensitive enough to detect iron if it were present. Other comets observed with the same equipment showed both nickel and iron, but the Tri-Atlas comet showed only nickel and nothing more. To understand why this is so surprising, one must delve into the temperature problem. At distances where the comet Tri-Atlas was observed, between 3·8 and 2·8 astronomical units from the Sun, the surface temperature is too low for solid metal to evaporate. Nickel has a melting point of 1455 degrees Celsius. Its boiling point, at which it turns into gas, is 29 to 13 degrees Celsius. The surface of the comet at 3 astronomical units does not even come close to that temperature. It may rise only a few dozen degrees above zero, possibly up to 100 degrees Celsius in direct sunlight, but not to 2,900. So how does the comet Tri-Atlas produce nickel gas? The standard explanation for comets is that nickel does not evaporate directly. It is contained in other compounds, carbonyl compounds, which can sublimate at lower temperatures and carry metal atoms with them. When these compounds decompose under sunlight, they release metal. This process is called the nickel-carbonyl channel and was proposed as a mechanism explaining how comets can display metallic emissions despite low surface temperatures. This explains the presence of nickel, but does not explain the absence of iron, as iron forms similar carbonyl compounds. If the process releases nickel, it should also release iron. Chemistry is not selective. Both metals should appear in ratios similar to their abundances in the composition of the comet. Either Trine and Atlas have no iron, or the ratio of nickel to iron is so distorted that only nickel can be detected. But it gets even more interesting. Nickel production was not constant. It has significantly increased. From July to August, Atlas moved from 3.88 astronomical units to 2.85 astronomical units. The rate of nickel extraction increased 25 times. In 1 month, 25 times more nickel was extracted. This is exponential growth, much faster than normal comet ejection patterns. By the end of August, 3 Atlas was extracting nickel at a speed described in scientific literature as extreme. The production rate was higher than any comet ever observed at similar distances from the Sun, and it accelerated as the object approached perihelion. Now let's talk about what this sign means on Earth. When people want to industrially purify nickel, when we need nickel free of iron contamination, we use a process called the Mond process or carbonyl process. You expose nickel to carbon monoxide at certain temperatures. Nickel reacts, forming nickel carbonyl, a volatile compound that can be separated from iron. Then you decompose nickel carbonyl at higher temperatures to obtain pure nickel. This is a standard industrial method for producing high-purity nickel, used in metallurgy and applications requiring nickel alloys free from iron contamination, demonstrating the extraction of nickel without corresponding iron extraction. This does not prove that the 3 and Atlas is artificial, nor does it prove that someone built it, but it means that the chemical signature we observe from this object corresponds more to an industrial process than to any natural one. The spectrum of Tri-Atlas resembles a nickel factory more than a comet. Could there be exotic natural chemistry creating this? Perhaps there could be. Conditions during formation in another star system may create metal ratios we have never encountered. Perhaps the carbonyl channel of nickel is somehow selective in ways we do not understand. There may be a physical process involving magnetic fields or electric discharges that prefers to release nickel instead of iron. But here lies the problem with such a statement. We observed many comets, hundreds from our solar system, and now 3 interstellar visitors, none of which displayed this sign of nickel without iron. If this is a natural process, if it's just strange chemistry from a strange formation environment, why are we seeing it only now? Why is 3 and Atlas an exception? A scientific article analyzing data from the VLT telescope is written neatly, as scientific publications should be. It describes observations that are extremely mysterious. It mentions that the presence of nickel and iron in the comet's coma is unexpected given the low temperatures. It is also noted that the object 3AI Atlas demonstrates extreme characteristics in terms of production speeds and the ratios of these metals. However, the authors do not dare to voice what anyone reading the article is likely thinking. It looks unnatural. This seems like an artificial influence. Avalov stated his position more directly. He publicly declared that the detection of nickel without iron is a sign known to be characteristic of industrial alloys produced using a carbon chemical pathway. He claims that, although a natural explanation may exist, the burden of proof now lies with those who must show what this natural explanation could be. Because at this moment, the simplest version corresponding to the observed data is related to the artificial production of nickel, which brings us back to the question of silence. If you are a space agency and you have spectroscopic data from orbiters on Mars during the flyby on October 3rd, you have almost certainly analyzed the chemical composition of 3 Atlas at a much closer distance than observations from the VLT telescope. You have better resolution, higher sensitivity, and more detailed spectra. What did these spectra show? More nickel and still no iron. Did the ratio increase even more upon closer observation? Have you discovered other elements, connections, or signs that make the industrial explanation more or less plausible? We do not know because this data has not been published. Observations from the VLT in July and August became available to the public, as they came from a ground telescope operated by an international consortium that publishes its data according to accepted scientific protocols. But the data from the Martian spacecraft goes through other channels, channels that can be suspended, channels that can be controlled. The sign of nickel is a clue, not definitive proof, not absolute certainty, but the strongest argument that the 3 Atlas may be something other than a natural comet. And somewhere in the data from October 3rd are observations that either confirm or refute this sign. Observations that may show even more extreme ratios of metals or perhaps demonstrate that upon closer inspection, iron finally appears and everything normalizes. In any case, these observations exist, and we are not allowed to see them. Chapter 8. The anomaly of 7 connects all points. We have already circled around individual elements of this puzzle: trajectory, the sign of nickel, coordinated silence. Now it's time to look at the bigger picture, because the 3 Atlas anomalies are not just 1, but a total of 7. And when you put them together, seeing how they are interconnected, the overall weight becomes hard to deny. When the Hubble telescope captured an object 3I Atlas on July 21, 2025, astronomers immediately noticed one unusual property. The object had a visible stream of scattered sunlight ahead of it, not behind, as is usually the case with comets, but towards the sun. This stream was 10 times wider than its width, forming a narrow jet of material, and strangely, no ordinary tail formed in the weeks following Hubble's observation. The typical appearance of a comet, a bright head with a long tail formed by solar wind, appeared only at the end of August, almost 2 months after its discovery. Comets usually form tails as they approach the sun. The closer they get, the stronger the solar wind, and the more pronounced the tail becomes. But the 3I Atlas first manifested this forward-directed flow, a stream pointing in the wrong direction, more resembling a jet from a nozzle than a natural eruption caused by solar heating. By the end of August, a faint tail finally appeared. The comet began to look more like a comet, but that initial stream, the 10-to-1 ratio, its unusual direction, it's not typical, it's not impossible, but it's not what you expect to see. And, finally, the dominance of carbon dioxide. When the James Webb Telescope and the Sphere X Observatory analyzed 3 Atlas in August, they discovered something remarkable. The gas cloud around the object, the coma, consisted of 95% carbon dioxide and only 5% water. This ratio is 8-to-1 carbon dioxide to water. Compared to the comets of our solar system, which usually have a predominance of water, most comets have a ratio closer to 1-to-1, or even with a predominant share of water. The ratio of 8-to-1 in reverse is exceptional. Carbon dioxide sublimates at lower temperatures than water ice. Dry ice, as we call it on Earth, turns into gas at minus 78 degrees Celsius at standard pressure. The ice of water requires 0 degrees, so a comet rich in carbon dioxide starts to become active at a greater distance from the sun than a water-rich comet, which corresponds exactly to what we observed with 3I Atlas. She exhibited activity at 4 whole astronomical units, much farther than comets usually awaken. The question is, why? Why does Atlas III have such an unusual composition? The answer likely lies in where it formed. Different regions of the galaxy, different protoplanetary disks, different lines of ice around various types of stars. All these factors influence what materials condense and in what ratios they appear. 3 and Atlas likely formed in an environment very different from the region of our solar system, possibly around an older, colder star, perhaps in an area with different elemental abundances. But here is where it connects to other anomalies. Carbon dioxide is not just another volatile component, it is also fuel. If you wanted to maneuver a spacecraft using cold gas engines, carbon dioxide would be an excellent choice. It is stable, easy to store, sublimate at accessible temperatures, and a spacecraft carrying large supplies of carbon dioxide ice could maintain the appearance of a comet while having enough material to adjust its trajectory. Is this what we are observing? Fuel reserves disguised as natural, volatile substances, or just unusual cometary chemistry? The composition alone is not enough to answer. In combination with a trajectory and nickel trace, this becomes yet another data point suitable for both natural and artificial explanations. Anomaly number 5. Extreme negative polarization. To understand this, one must know how light behaves. When sunlight reflects off a surface, it can become polarized, meaning the light waves a line in a certain direction. The degree and type of polarization reveal information about the reflecting surface, its texture, composition, and structure. The body named Tri-Eye Atlas demonstrates extreme negative polarization. Polarization measurements exceed the normal range for comets, significantly surpassing it. This indicates unusual properties of the surface or the dust particles in the coma, differences in shape, composition, or structure. Negative polarization can occur in certain types of particles, very fine grains with unusual mineralogy, specific shapes, and alignment. However, extreme negative polarization is a rarity that requires explanation. Some researchers suggest that this may indicate the presence of unusual minerals formed in the environment from which the Tri-Eye Atlas originated. Others note that artificially created particles, especially certain types of engineering materials, can cause strong negative polarization. This is not definitive proof in any direction, but it is another property that does not quite fit the typical profile of a comet. Anomaly number 7. Alignment with the WOW signal. On August 15, 1977, the Big Ear radio telescope at Ohio University detected a strong narrowband radio signal at a frequency of 1420.4 MHz. This is the hydrogen line frequency, and the signal lasted for 72 seconds. It was so unusual and potentially significant that astronomer Jerry Amon wrote "wow" in the margins of a computer printout. This signal was never recorded again, repeated, or explained. The signal came from the direction of Sagittarius, with a right ascension of 19 hours 25 minutes and a declination of -27 degrees. This is the general direction towards the center of our galaxy, where hundreds of billions of stars gather in the galactic core. Now, here's an unpleasant coincidence. When tracing the trajectory of Tri-Eye Atlas back to 1977, it was approximately 600 astronomical units from Earth, with its position in the sky only 9 degrees in right ascension and 8 degrees in declination from the origin of the WOW signal. 9 degrees out of 360. The probability that this alignment is random is about 0.6%, 6 out of 1,000. Could the Tri-Eye Atlas have transmitted a signal WOW? If this were located 600 astronomical units away, detecting it would require a power of half to 2 gigawatts, comparable to the output of a typical nuclear power plant on Earth. Significant power, but not impossible, and the blue shift of the signal indicates that the source is approaching Earth, corresponding to the trajectory of Object 3.I Atlas. Perhaps the WOW signal was a radar pulse, a scanning beam moving through space, pinging neighboring star systems to detect planets, and we found ourselves in this beam for 72 seconds as it passed by. If 3 Atlas discovered planets in our habitable zone during this scanning, perhaps he slightly adjusted his trajectory, accelerating for a faster arrival. When he reaches us in 2025, he will have been on the road for 48 years since that discovery in 1977. All coincidences are pure chance. 6 out of 1,000. Unlikely, but not impossible. This is yet another argument that can be interpreted in different ways. Here is what all 7 anomalies tell us when considered together. Each can be explained separately. The size may be a statistical coincidence. The front jet stream may have unusual exhaust geometry. A nickel signal may indicate exotic chemistry. The prevalence of carbon dioxide could be related to formation conditions. Polarization might suggest strange properties of dust. The trajectory could be a result of randomness. The WOW signal coincidence may simply be a coincidence. But all 7 together, then the natural explanation begins to require more and more caveats. More and more unlikely circumstances that coincide in one object. It's not impossible, but it is unlikely. And the more that is added, the less likely it becomes. Avi Loeb assigned 3 Atlas ratings on his Loeb scale, which ranges from 0, definitely natural, to 10, definitely artificial, and potentially hostile. Currently, he rates it between 2 and 4, not 0, not naturally default, but not high enough to declare anything definitive, right in the unclear middle, where more data is needed for a final conclusion. And here we are. We have been in this uncertain situation since October 3rd, waiting for data that exists but has not been published, waiting for space agencies to break their silence. We wait to see if these 7 anomalies will be explained by the 7 spacecraft as natural processes, or if they will be confirmed by additional observations, making the hypothesis of artificial origin harder to ignore. The data exists. Observations have been made, analysis conducted. Somewhere, people know whether these anomalies are resolved or intensified upon close examination. They know they reveal images from the 3rd of October. They know they uncover spectra. They know they indicate thermal signatures. They know, and they are not telling us, not now.